Hi, I'm here today to talk about the three different potentials: resting, local, and action. We will start with the resting potential. Here is a neuron, and as you can see on the outside of the plasma membrane is the ECF, which stands for extracellular fluid. On the inside is the intracellular fluid, also referred to as the ICF. The ECF contains positive charged sodium ions, and the ICF contains positively charged potassium ions and protein ions. However, the protein ions will never be able to escape due to their large size. Here's a closer look inside the neuron. Here you can see the two gates, which is the sodium gate and the potassium gate. During the resting potential, the gates are closed because the neuron is at rest, which means there's no signal, but is ready and waiting to send a signal down the length. The resting potential is at a negative 70 millivolts, and this is also known as being in a polarized state. Next, we will discuss the local potential. At local potential, a chemical stimulus is sent from the central nervous system down to the dendrites. From the dendrites, it is received and passed along through the soma to the axon hillox, which is also known as the trigger zone. The signal must have a difference of at least 15 millivolts in order to pass through, which means it needs to go from at least negative 70 to negative 55 millivolts. There are three main characteristics for the local potential. One is that it's graded, which means there's a variance in voltage according to the strength of the stimulus. The next one is decremental. This means it gets weaker as they spread from point of stimulation. This is what prevents the local potential from having long distance effects. The last one is that it is reversible. If stimulation ceases, cations diffuse out of the cell and returns voltage to the resting potential. Lastly, we will discuss the action potential. During the action potential, stimulus is passed through the axon hillox. This also has three different characteristics to it. One is that it's non-graded. It follows an all or nothing law, which means that it does not have varying stimulus strength. The next is that it's non-detrimental. This means that they do not get weaker with distance. And they are irreversible, which means they cannot be stopped once it begins. There are two different stages to the action potential. Step one is depolarization. This happens between negative 55 millivolts and plus 35 millivolts. During this stage, sodium gate opens and transfers sodium ions from the ECF to the ICF. The potassium gate is still closed though. On to step two. It's called repolarization. This is when the sodium gate closes and the potassium gate opens, letting potassium pass through to the ECF. Once this is done, it returns neurons back to the negative 70 millivolts and starts over. Thank you.